tell you, and I'm recording this thing. Albert I.O. I just added a new one today. There's a total of 3 for this quarter. There was 10 questions, SAT practice 1. 10 questions for SAT practice 2. And I just added one that has 9 questions. They are all open until Friday at midnight. I'm giving you guys an opportunity to finish those 3 and still get full credit, okay? So I'm going to keep reminding you, or I'm going to try to keep reminding you. I'm really bad about it. I need you guys to be on top of it. Next quarter, I'm going to be a little bit more strict with it. Like, you're going to have really firm due dates, okay? There's a lot of time in class. A lot of you finish your homework in class and then just go on your phones. So use that time, please, to finish, like, just make sure you get your Albert I.O. done, okay? Remind each other, all that stuff. It's an easy, easy chunk of homework points, okay? So all 3 of them are due on Friday. Even though some of them will say late, I'm still counting it, okay? And tomorrow, listen, tomorrow I'm going to do a homework check. I'm going to check 2 to 3 of them. I'm not sure yet. And any homeworks that you don't have turned in, like, go into focus, guys. See anything that you did not get 4 out of 4 on. And if you want to get credit for it, some incomplete credit, but a little bit more points, just show it to me by Friday. Everything is due Friday. Albert I.O., any old homeworks, tests, quizzes, all that stuff. Now, we are having a test on Friday. So obviously, if you're not here Friday, I will let you make it up next week. Okay? But I'm talking about any of the older stuff as far as tests and stuff. So Albert I.O. and homework due Friday. Last test Friday. Homework check tomorrow. Okay? So bring everything with you and be ready. Okay? Good? Yes? This is the last assignment, like I said. Tomorrow is, we're going to start our test review. Then I won't see you guys on Wednesday. Remember, Wednesday is PSAT, SAT. So we're going to start the test review tomorrow and finish it on Thursday. It'll be 1 assignment. We'll work on it for 2 days. Friday will be the test. Okay? All right. So we have been graphing quadratics. You guys have been doing a really good job. There's 3 different types we graphed last week. Those all 3 will be on your review tomorrow, okay? This is like an oddball one. This assignment is very, very different from all that stuff we've been doing. And I say day 1 because there's a whole bunch of 3.3 we're not going to get to until next week, so it'll go on the next quarter. So just know that there's a day 1, and we'll do like 3.3 day 2 next Tuesday because you guys don't have school Monday. You don't have school Monday. All right, so guys, first thing we need to know is what perfect squares are, okay? Perfect squares is a whole list of numbers. It's the numbers that when you multiply, like 1 times 1, you get 1. 2 times 2, and 3 times 3. This is not something you need to memorize. This is something you could pick up your calculator and make a list of these numbers. And it is definitely helpful to make a list of these numbers. So I'm just in my head going 6 times 6, 7 times 7, 8 times 8, and so on. Okay, I'm going to keep listing them. 9. They go on forever. Okay, so that's what the dot, dot, dot means. Right? These are called perfect squares. So if you did the square root of any of these numbers, you'd get a whole number, no decimals. Like the square root of 25 is 5. Why? Because 5 times 5 is 25. And you guys know there's a square root button on your calculator. It's right above the x squared. It's in blue, so you would have to hit the second button, and then that, and then like you could put a perfect square in there. Okay, so perfect squares. Now, what we're going to talk about is something completely new. I don't know if you've talked about it in any other math class. I don't think we do it in Algebra 1. It's not a geometry concept. So this might be brand new. But you've been told forever that you can't take the square root of a negative number. And technically you can't. See how it says non-real answer? Technically, you can't in the real number system. So the numbers that we've been working with forever are called real numbers. There is a whole other set of numbers called imaginary. And they come from a negative under a radical. So the square root of a negative number is considered imaginary. And it's a funny kind of way of thinking about it. It's like imaginary, but it's just something they give it. That's just what they call it. And it's always denoted by a lowercase I. It looks like it's just a lower, and it's a variable, guys, just like X or Y. So when you see an I in one of your answers, it means There was an imaginary number in it. Okay, so I'm going to give you two pieces of information here, and I'll explain how we're going to use it. So if you get a negative under a radical, that would be the square root of 1 is 1, and then you would just have an I. And you could put a 1 in front of it if you wanted to. Where am I? If you get two i's, meaning I times I, it cancels out and becomes a negative 1. So these are really, really important concepts that we're going to use, and I'll remind you of this in a second. Okay, thanks. Okay, here's the thing. I want you to look at all of these examples here. Every single one of them has a negative under the radical. Okay? The first thing you do in all of these problems is get rid of the negative under the radical by making it an I on the outside. Okay? So we're going to do more to it than that, but the number one thing I want you guys to notice is that when you see a negative under the radical, it simply is going to make it an I out in front. I don't know why I gave you my calculator. You can use the calculator on your desk or mine. It's fine. The pink one, maybe it'll bring you good luck. Okay, so the negative came out and became an I. Okay, that's going to happen on all of these. All of these are going to have an I in front. But that's not the end of the problem. First thing we're going to do when we simplify is say, is this a perfect square? Is this one of the numbers in my list? Yeah. What's the square root of 25? 5. So the answer is just 5I. Okay, why is there an I there? Because of the negative. And it's just like a variable, like 5x. That's why we put it after it, 5I. That's the answer, okay? So always look and see if it's in your list, all right? Then look what happens if it's not, okay? The negative has to come out and become an I. And I think you guys will notice 75 is not in your list of perfect squares. So it's kind of like when you have to simplify a fraction, right? Like 4/8. You're going to just divide the top and the bottom by two numbers. What you want to do here is ask yourself, what two numbers multiply to get 75, where one of them is in this list? What number goes into 75 where one that's in this list? 25, right? So look, I'm going to break 75 down to 25 and 3, okay? The square root of 25 times the square root of 3 equals 75. And don't forget, there's an I hanging out in front. He's just tagging along. What's the square root of 25? 5. So this becomes 5. Does the square root of 3 become anything other than just a decimal? No. So the final answer is the 5 and the I. Those go on the outside. And then that 3 is stuck inside the radical. The trick is knowing, did I go far enough? Is there anything else I could do to simplify that? And we'll see that in a second. I'll talk about that more. Okay, so look, first thing I notice is there's a negative. I go, you can't be in there. Not allowed. Okay, just doing that would give you some credit, even if you didn't simplify the other number, okay? Now, is there a number in that list that goes into 11? Besides 1. I mean, 1 is technically a perfect square, but if I multiply 1 times something to get that number, it's not going to change it, right? 1 times 11 is 11, but what's the square root of 1? Just 1. So we don't really use 1 in these types of problems. But is there anything else in that list that goes into 11? No, that means you're done. It can't go any further. Okay? Sometimes there isn't any more simplifying to do. Okay, let's do a harder one. That says negative 80. Okay, negative 80. You definitely want to bring the negative out, right? Cannot stay in there. It comes out and becomes an I. Is there a number in that list that goes into 80? 4 does. Yeah. So let's watch, and 4 is fine. So did anybody want to say anything besides 4? Okay, I'm glad you said that, JT. there's a lot of numbers that go into 80, right? It's an even number, so it's divisible by 2. 4 goes into it, 5 goes into it, 10 goes into it, 20 goes into it. We don't care about any number unless it's in this list, okay? So that's why it's nice to have this list. Then you can, like, focus on just those numbers. So, yeah. So I'm going to stick with 4. Here's the thing. I'm going to stick with 4 because that was what you guys said first, and then I'll go back to the idea of 16. Because most of us, we find a number that goes into it and we're really excited and it's fine. We're going to stick with it, okay? So we're going to say 4. And then how do I know what the other number is? I divided 80 by 4 and got 20, right? And as I just showed you, the square root of 4 is 2. So I have 2i square roots of 20. But can't 20 break down again? 20 can become what? 4 and 5. Sorry, I'm really squeezing it in here. That would be the square root of 4 times the square root of 5. Okay, that 2i is still out in front, okay, so I'm just bringing it down. When I do the square root of 4, I get fill up that part? Oh, filled it out. Let me know who that is. I would fix their little Sorry. Yeah, sure. Okay, so the square root of 4 is 2. Now what do we do? And I'm so sorry, I'm squeezing right here. The 5 is under the radical, can't do anything there. What do you think we do with this 2 and this 2i? Multiply. Okay? Now, I'm just going to go over here. So I have the 2 that came out of here times the 2i is 4i, and the square root of 5. Okay? But let me show you, because some of you, after I started talking about it, I heard somebody go, oh, wait, 16 goes into it. Let me show you guys an example. Okay? I always think about radicals like fractions. So just look. If I said you guys simplify this fraction without a calculator, if I said simplify it, some of you might be like, ooh, I can just cancel a 0. There I go. But did we simplify it all the way? No, but was it a big deal? No, you could just be like, okay, I divide both of these by 5, and I get 1/2, right? As long as you get to the end, it doesn't matter how many steps. Some of you might have looked at that and said, oh, I can go right to 1/2. Who cares, right? You get the same answer. Nobody's wrong here, okay? I think of radicals the same way. Somebody might have just seen the 4 and the 20, and that's fine, and they just had to break it down twice like we did. But some of you might have seen that there's a bigger number that goes into it. And if you did, great, because guess what? This can be done in one step. We get 4 square roots of 5, okay? Which is what we had here, except the imaginary number. I just got to it in one step. So the idea is when you get kind of bigger numbers, you might want to take an extra second and ask yourself, like I don't expect anyone to know that 80 is divisible by 16 off the top of their head. Like, it's not normal for you guys to go, oh, 80, that's 16 times 5. If you know it, awesome, but look, you could play with it. Start dividing 80 by different numbers. And if you get, it goes into it evenly, you found another perfect square. Of course, you might try other numbers. Oop, 9 doesn't go into it. Does 25 go into it? No, we shouldn't be getting decimals is the whole point. Okay, so I'll practice that with you some more. Okay, so let's look at same idea, but one step extra, which is multiplying. The first step is get rid of those negatives under the radical. That's the first step in every single one of these problems. So this is going to become I square roots of 10 times I square roots of 15. Okay? You have to get rid of the negative first. Then you can just multiply everything together. Anything on the outside gets multiplied together. So I times I is I squared. Yeah. Just like x times x is x squared, I times I is I squared. And 10 times 15 is 150. Now, sometimes this can be simplified, sometimes it can't. What do you guys think? Pick up your calculator. Is there a number in that list? Don't just divide by anything. You always want to use these numbers. Is there a number in that list that goes into 150? 25, right? divide 150 by 25, and I get 6. So, I would get 25 and 6. I'm just breaking it into 2. 25 times 6 is 150. Notice we're still under the radical. The square root of 25 is 5. And 6 can't be broken down anymore. There's not a number in that list that goes into 6. Think about it. Try it. And then what does I squared equal? I gave it to you way at the beginning of the notes. -1. So if I do -1 times 5, it just changes the sign to a negative. So I squared just changes the sign. Makes it negative if it's positive, makes it positive if it's negative. You're multiplying by -1. Okay? Let's do another one of those. First thing I do is take that negative out. Don't forget to do that. And what I hope you guys notice on this example is something special about 16 and 25. They're both perfect squares, right? So just like back in example A, right away, I wanted you to, you want to really start recognizing these numbers. You're allowed to write the list on the top of your test, just like we did at the top of our notes, but the more you work with them, the more you'll see. So the square root of 16 is 4. So bring it out front, and there's an I, so that just becomes 4I. This one would become what? 5I. What do you think we do with those two? Multiply them, right? It says multiplication. 4 times 5 is 20. I times I is I squared. And you don't have to write this step, but just like you guys told me a minute ago, I squared is the same as -1. It just changes the positive 20 to a negative 20. So sometimes you don't have a radical left in your answer. That's okay. And sometimes you do have a radical left in your answer. Let's do one more. First step, all of these problems, is make sure you take care of that imaginary number by, it's like designating it. Like, there was a negative under this radical, I'm going to make sure I show that that happened by putting an I out in front. Okay? And 8 and 2 are not perfect squares, so I'm just going to multiply the i's together and the radicals together. 8 times 2. What do we know about 16? It's a perfect square, right? It's a perfect square. And we know I squared equals -1, right? I squared equals -1. The square root of 16 is 4. Our final answer, -4. So you can see where there's going to be some places where we can get confused, like, wait, is there a radical in the answer or not? Like right here is a common mistake. Some students will now make that like a 2. That 4 is not under the radical anymore, right? The square root of 16 equals just 4, not the square root of 4. So be careful, like when we work on the homework right now, really try and pay attention to like the differences in the problems. Okay, because this is something new I'm throwing at you on a Monday. Okay? So if you weren't here last week and you didn't rip out these pages, you do need those, but if you ripped out your pages, this is one of the ones I had you rip out. So see if you have 153, and I will get you started. Then you guys should have time after to work on Albert I.O. if you haven't yet. Yeah. Okay. Any of you that have a test that you still have to make up, don't forget, Friday is the deadline. So homework is due Friday. Albert I.O. is due Friday. Okay. So let's go to the homework. Say it again. Listen, let me tell you, that's a great, I have to retake. The actual makeups for the test, that if you've missed it, on Wednesday when you guys have SAT and PSAT, you're going to go to 6th and 7th period, and I doubt your teacher is going to be doing anything. So if you can get a pass to come to here 6th or 7th, you could make up the test then, okay? Like, I'm not doing anything with my pre-calc kids. They're just going to come and hang out. So if you are just hanging out in your class and want to come make up a test, you could. All right, guys, let's start the homework. If it helps you, if you have your notes nearby, or remember, if I were taking this test on Friday, I would, before I even start the test, I would put a list of the perfect squares at the top of my paper. Just it makes it easier to look at. So just, I would have your notes nearby so you could look at these, unless you've worked with them a lot before and you're really comfortable with them. Okay, don't forget the first step is to take the I out. It's really important. So that negative became an I on the outside. And 48 is one of those numbers that has several factors. Factors are numbers that go into a number evenly that are perfect squares. Does anybody start with anything with 48? How do you know? How do you know what to do? If you have the number 48 and you're like, I don't know what goes into it, 2 and 24, those aren't on the list. Remember, take your list of numbers and divide it. Yeah, 4 goes into it, but 16 is a bigger number. If you can find the bigger number, you have fewer steps to do. So 48, you tried 4. When I do divided by 4, I see that I get 12, and I know 4 goes into 12. So I know I'm going to have to do it a second time, which is not wrong. It's just more work. So sometimes I would look at that and be like, oh, let me see if there's a bigger number. And 16 is that bigger number. So 48 would become the square root of 16 times the square root of 3. The I just comes and hangs out. The reason we chose that 16 is because it's a perfect square, right? It's a 4. And then let's put the I after it. Like we don't write x4, we wouldn't write I4, we put 4I. Okay, that's what those two just became. And the square root of 3, there's nothing else we can do with it. Okay, let me make sure you guys know something. When you see a negative under the radical, I wanted to say it at the beginning and I forgot. It does not equal a negative answer. Okay, a negative under the radical is not a negative answer. Okay, so a negative under the radical makes an imaginary answer. Just so that's a really common mistake students make. Now I'm going to put the key up. Please don't just copy it. It's short. You can get lots of help from me and not copy and leave here feeling good about the assignment. Please, 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 please don't just copy answers. I'm sorry? No, I just can't really zoom in on it. I will move it. I'm going to move it. There's 3 more. Believe it or not, I'm not an unreasonable person. When you get to number 7, I'm not going to ask you to simplify it to a huge number like that. So if you get something like that in the thousands, you should just know it's not simplifiable. Okay? So when you get to that one. If anyone can't see wants to take a picture of it, feel free to come up and do that.